This video is about making visualizations using Python. I will be using iris data. We will start with descriptive statistics and then we will move to visualizations such as histogram, box plot, scatter plot, line graph, violin plot, and pie chart. Before you start working, you need to create a new file, and for that purpose click on Explorer and then create a new file by clicking on this new file. I have created a file and I have named it iris, and you can see the extension is interactive Python notebook. Once you have opened a new file, the very first step is to install libraries. And every time you open a new file or reopen a saved file, you need to install these libraries and run them. To make visualizations, the most relevant libraries are pandas, matplotlib, numpy, and seaborn. So make sure you use this command pip install pandas, matplotlib, numpy, and seaborn. Run this command by clicking on this one or shift enter. So as you can see, these libraries have been installed. Now the next step is to import these libraries. So we import pandas as pd, import numpy as np, import seaborn as sns, and matplotlib as plt, and import matplotlib.pyplot as plt. I will run this command. This green tick shows that these libraries have been successfully imported. Then the next step is to import data, and for this purpose I will be using iris data. So this is the basic command that I'll be using. Iris is the name of the file. You can change it, you can give it any other name you choose, and then pd.read_csv, and then there is destination path where your file is. So in my case, this is the path of destination, but in your computer it will be different. So make sure you are using the right path. This path is specified as double quote and then slash and then that specific path where your file is. If you don't know what is the path of your file and you are using MacBook, then you can click on the folder and then click on get info, and then it will show you the path. So make sure you are using the right path, then execute this command, and then I want to see if my data is imported. I will use these commands iris.head and it will show me the top 6 rows, showing me top 6 rows including the header row. It shows me the name of variables, sepal length, sepal width, petal length, petal width, and species. And if I want to see bottom 6 rows, then I will use this command, that's iris.tail. Iris is the name of the file and tail and then parentheses, and if I run it, it shows me bottom 6 rows of my data. So as you can see here, there are 149 observations and the 150th one is header. Now for this data, I'll be using only this variable sepal length. Here are two important things to note. One is my file and the name of the file is iris, and then this file, iris file, has many variables like sepal length, sepal width, petal length, and petal width. I'll be using only sepal length, so that's my variable. Now in all my codes, when I'll be making visualizations, I need to specify this name of this variable, and I have two options. One option is that I specify the whole path, which means specifying first the name of the file followed by a name of the variable, or I define this variable separately. So we have two options here. When we want to use these variables, our first option is to specify file name, which in this case is iris, followed by variable name. So which means we will have to use this type of command, iris file name followed by variable name. The second option is that we define sepal length as a variable. In that case, it will be sepal length is equal to file name and followed by variable name. And once I define this sepal length as a variable, then I can only use sepal length. Here is an example. I want to make a scatter plot of two variables. One is sepal length and other is petal length. Scatter plot requires two variables. One variable is on x-axis and other variable is on y-axis. First of all, this is the basic command. The basic command is this one, which means plt, which comes from matplotlib, plt.scatter and then first variable x variable and followed by second variable or y variable. So this is the basic command that I'll be using. So first option is that I use this basic command plt.scatter, and then I specify the whole path, which means first the name of the file and then the name of the variable. And then similarly for y variable, again I specify the name of the file, which is iris, followed by the name of the variable. If I run it, it will make a scatter plot. Another option is that instead of specifying the name of the file, I define sepal as a variable. So in that case, this variable will become sepal is equal to iris and then sepal length. Similarly, I define petal length as name of the file followed by name of the variable. Now, once I have defined them as separate variables, I can use this command, that's plt.scatter, then simply the name of variable. As you can see here, I am not using here iris or file name. I am only using variable name. Similarly, for y variable, I am not using file name, which means I am not using iris here. I am only using the variable name, and that will work perfectly. So you can see here the same plot we get. I prefer this one because this is shorter. For the rest of the video, I'll be using this approach, which means I'll be defining these variables and then I'll be only using them. So make sure that these variables are defined upfront when you want to use them. I define this variable. So my variable is sepal length is equal to iris, which is the name of the file followed by name of the variable. So for example, if we want to calculate the mean, and for mean calculation, the basic command is this one, np.mean and then name of variable. Now again, we have two options. One option is I use this basic command, that's np.mean followed by the whole path, and whole path is the name of the file and then variable name. The other option is I use only the name of the variable. Mean is equal to np.mean, that's our basic command, followed by the name of the variable. I will start with descriptive statistics, and as you can see here, whenever there is a hash symbol, it means it is not considered as a code. It is just information. So whenever you want to add some information which is not a code, you start with hash. To calculate mean, I'll be using this code. Mean is equal to np.mean, np comes from numpy, and then the name of the variable, that's sepal length. That will give you the mean, and in order to show it, we need to use this one, print mean. So if I execute this command, it gives us the mean, that's 5.8433. We want to make it more informative, and for that purpose, I will add here more information, which means print mean of sepal length, quotes, and then mean. I am asking Python to show in the results that this is the mean of sepal length. If I run it, that shows mean of sepal length. So just adding this part makes these results more informative. For median, we'll be using this command, that's np.median followed by the name of the variable. For standard deviation, we use this command, np.std followed by name of the variable, and then we will print it. For mode, we will use this one, variable name dot mode and then parenthesis. For first quartile, we use this command, np.percentile variable name and then 25. 25 represents first quartile, so that will be first quartile. If we want to calculate second quartile, the code remains essentially the same. The only difference is that we make it 50 because 50 represents second quartile. For third quartile, again the code remains the same, but we make it 75 because 75 represents the third quartile. And if I run this command, it gives us this information. As you can see, mean, median, standard deviation, mode, first quartile, second quartile, and third quartile. Now over here, we have used multiple codes for descriptive statistics. Is it possible to get this information using only one code? So this is the one whereby we will calculate descriptive statistics using only one code, and that will be describe. Descriptive is the name of the variable I created. You can choose a different one, and it is equal to sepalength dot describe and then parentheses open and close. And then if you print it, print descriptive, which means show me what is descriptive statistics. And if you run this command, it shows us this thing. It says there are 150 rows, mean is 5.84, standard deviation minimum, first quartile, second quartile, third quartile maximum. The next one is making visualizations, and we will start with the histogram. And for making histogram, the basic command is this one, that's plt.hist and then variable name. Variable name in this case is sepalength. So this is our basic command, plt.hist and sepalength, and if I execute this command, it has made this histogram. But we can change it, we can add more information. So we can add here number of bins, we can make it 5, 6 or 7. And if I execute this command after adding this number of bins, then it gives me this type of histogram, which looks a little bit better than the previous one. So this is the basic minimum code for making a histogram. But this is not sufficient. We also need to add here some aesthetics. We also need to add here information about x-axis and y-axis and title. So for x-axis, we use this information, plt.xlabel, and then this is x-axis label, whereby you have a choice. You can choose any name you want to use. And for y-axis, the code will be plt.ylabel and then count or frequency. And then plot title is histogram of sepalength. Again, for this part, you have a choice. So this is the code. You don't have a choice here. You don't have a choice here and no choice here. But within parentheses, what name you want to give, you have a choice. So again, this is the basic code and this is aesthetics. The next one is box plot, and for box plot, the basic code is plt.boxplot and then variable name. So here I use this code plt.boxplot and then sepalength, and then this is aesthetics, plt.title, and then this is the title that I wanted. And if I run it, it makes this box plot of sepalength. The next one is scatter plot. For scatter plot, the basic command is this one, plt.scatter, name of first variable, x variable, and then y variable. I define sepalength as a variable and petal length as a variable, and then in my code I use this command, that's plot.scatter and then sepalength and petal length. And if I run it, so it has made this one. You can add here more aesthetics by adding this information. So after I add this aesthetics and if I execute this command, it shows me all this information. This is sepalength, this is petal length, and this is the title. But the basic command is this one. The next one is making a violin plot, and for violin plot, the basic code is this one, plt.violin and then variable name. And for this one, we'll be using only one variable. So again, I'll be using only sepalength. So this is the code for violin plot, plt.violin and then name of the variable, that's sepalength, and then the rest is aesthetics. So if I run this command, it makes this type of violin plot, and as you can see, it shows there is more density of data in this range from 5 to 6.5 and less at the bottom and at the top. The next one is line graph, and for line graph, this is the basic code for line plot, plt.plot and then variable name comma marker is equal to O, this is O not 0, and then line style is equal to hyphen within quotes. This is the basic command, and then we'll be adding some aesthetics to this one. So this is aesthetics, this part. If I run this command, it makes this type of line graph, so whereby we have line graph of sepalength, this is index, and this is sepalength, and this is the title. The next one is making a bar plot. So here's a bar plot, how it looks like. As you can see, it shows one bar for sepal length, sepal width, petal length, and petal width. Making a bar plot is a two-step process. Let me explain it by showing you data. So this is our data, whereby we have iris.head and it will show us top 6 rows. If I execute this command, it shows us this thing. So I want to make a bar plot where there will be a separate bar for sepal length, sepal width, petal length, and petal width. And as you can see, there are multiple values and there are 149 rows. So in order to make a bar plot, we need to convert these values into a mean. So we need to have one value of sepal length, one value of sepal width, a mean of petal length, and a mean of petal width. So making a bar plot will be a two-step process. In the first step, we will calculate mean of these four variables, and then we will construct a bar plot. So in order to calculate mean, I will define them as a separate variable, mean of sepal length, and I'm using this one iris, and then sepal length and dot mean. I will define all of them as separate variables, which mean mean of sepal length is equal to, this is the name of the file, name of the variable, and dot mean and parentheses. The same applies to all four variables. And if I execute this command, it will calculate the mean. While we had here 149 values for each variable, but this one converts them into one mean. So here we have one value for sepal length, one value for sepal width for this one and this one. Now we can make a bar plot. So after calculating mean, the next step is to use this command. We will make labels. I will be using these labels: sepal length, sepal width, petal length, and petal width. And the next thing is mean. And our code is this one. That's plt.bar and labels, comma means. We have already defined labels and means. And then this code is basically sufficient, but if you want to add more aesthetics, we need to add some colors to that. So if I execute this basic code, then it will give us this type of bar plot. But if you want to make it more colorful, then I will add here some colors. So the same code, but I just add here some colors like turquoise, green, red, and pink. And if I run this command, then it makes this type of bar plot, which is much better than the previous one. The last one is pie chart. And pie chart also comprises two steps. In the first step, we will calculate count. Pie chart is about count of categories. This is our data, and as you can see in this data, we have three species. One is Setosa, and other one is versicolor. These are species of flowers, and then the last one is Virginica. So we have three species here. Making a pie chart is a two-step process. The first step is the count of these species. So for that purpose, we use this code. Species counts is equal to iris species, so which means this is a file name and this is variable name, and then this is a code dot value counts and then parentheses, and that provides the count of each of these three species. And then the next one is what is the size of the plot. So it is not really necessary, we can also do without it. This is the code plt.py and then species count, that's the variable we just created that tells us count of each of these three species, and then this is labels, and then auto %, and then that's the colors that I want. You can change colors, and then start angle. If I run this, it makes this type of pie chart. If you want to make it bigger, you can add here this information, that's a plot figure size is equal to 8 by 8 inches. And if I execute this command, you can see it's a little bit bigger. That's all about descriptive statistics and making visualizations using Python. And as you can see here, this black dot, it means my work is not saved. So I can just press Command S and this file will be saved in the folder. And whenever you want to restart working on that, make sure you install these libraries and import them.